Okay. Sige, let us continue our discussion about Le Chatelier's principle and about electrolytes. So last meeting, diba, we discussed that when you say Le Chatelier's principle, it's an attempt of a system in equilibrium to get rid of the stress. So what are the examples of stress? We have pressure, which affects only our gases, and then changes in concentration and also change in temperature. All of them, class, will cause stress in a system supposedly in equilibrium. Therefore, there will be shifting, okay? Mag-shift either to the left or to the right, or forward or reverse reactions para ma-neutralize or to get rid of that stress. Okay? Yan yung lesson natin last meeting. And then actually, I have started now with the ionization of electrolytes. Do not forget, when you say electrolytes, these are substances that when dissolved in water will give off ions. Okay? Magkakaroon ng ions. Therefore, class, electrolytes conduct electricity. Remember, ions are charged atoms, charged particles. So definitely, if magkakaroon ng mga ions, there will be conduction of electricity. Okay, if you are asked, electrolytes again are able to conduct electricity. Now, pag strong electrolytes, ito yung completely mag-ionize in water. So like all of the particles will have charges. Walang particles na maiiwan na neutral. So ito, magkakandak ito ng electricity. Ito namang weak electrolytes, magkakandak pa rin naman ng electricity pero at a lower extent compared to that of the strong electrolyte. It is called weak electrolyte because partial lang yung ionization. When you say partial, that means not all of the particles will have charges. Okay? Incomplete yung ionization. That's what you mean by weak electrolytes. And then I ended here with acids and bases. Kasi acids and bases, class, are also considered electrolytes. When you place an acid in water, the acid class will completely ionize if it is a strong acid, and partial ionization naman if a weak acid. So again, acids and bases are considered as electrolytes. And how do we determine acids and bases? We may look at these theories. Okay? For Arrhenius theory, it is said that an acid gives off a hydrogen ion, or H3O plus is called hydronium ion, while bases will give off hydroxide ion. Now, however, our problem, not all acids and base contain hydrogen and hydroxide. Thus, we have additional theories like the Bronsted and the Lewis theory. For you to remember them easily, we have low rate for proton and then Lewis E for electrons. And then you have to identify kung donor ba or acceptor of either protons or electrons. So, hindi dapat magkabaliktad yan. Bronsted for proton, but acid is a proton donor and base is a proton acceptor. Now, it's the reverse for the Lewis theory because acid is an electron acceptor this time and base is an electron pair donor. Okay, so again, if an acid does not contain hydrogen or a base does not contain hydroxide, then we may follow either this one or this one. Depende kung proton donor or acceptor or electron pair acceptor or donor naman. Okay, pwede pa rin nating matawag yun as acid or base. Okay, now let us move on. We have here weak acid. So again, pag sinabing weak acid, it is still an electrolyte, but this will just partially dissociate. When you say dissociation, it is classed the breaking of the acid into ions. Okay? So magkakaroon ng ions, charged particles, pero partial lang. It means not all the particles will have charges. Some will be neutral. Okay? So, ang ibig sabihin ng weak acid, it will not release all of its hydrogen in the solution. Kasi diba, according to Arrhenius theory, acid daw will release hydrogen. Pero pag weak acid, hindi lahat ng hydrogen mare-release. So, let us have an example. It's not connected. Okay. So let us have an example. Example class HCl. Do you read HCl? What is the name of the HCl?
Hydrochloric acid, ma'am.
Okay, very good. That's hydrochloric acid. Now, if you are going to place hydrochloric acid in water, it will give hydrogen and chlorine. So definitely, since isa lang yung hydrogen niya, and then pagkatapos ni-release pa talaga when dissolved in water, HCl is considered a strong acid. Now, for the weak acid, let us have the acid in vinegar. That's the acetic acid. This is class your acetic acid. Now, acetic acid again is considered as weak electrolyte. Bakit? If this dissociates in water, it will give this one. An acetate ion plus a hydrogen ion. So as you can see, hindi lahat ng hydrogen mare-release. Meron kang tatlong hydrogen dyan na nakasali sa polyatomic ion. Isang hydrogen lang yung na-release. Again, that is the reason why acetic acid is considered a weak acid. The rest of the acids that are able to release all of its hydrogen are considered strong ones. Okay? So I hope that is clear. Now, these acids have higher pKa than strong acids, which release all of their hydrogen atoms when dissolved in water. So remember our Strensen system for the pH. So remember class, pag ang pH ng substance ay 7, it is called neutral. The solution is neutral. But if it is higher than 7, the substance is basic or we call it alkaline. Now, paano pag below 7? This time, our substance is acidic. So, the more class na mababa yung pH, the stronger, excuse me, the stronger the acid is. Okay? Please take note of that. Kapag mababa yung pH, the stronger the acid is. Kasi merong mga acid class na substance na ang pH ay 6, this is considered a weaker one compared to a substance having a pH of 2. This one is stronger. But please take note that if you have low pH, it means you also have low pKa. Later, I will discuss what pKa is. This is actually the dissociation power of the acid. Kasi, di ba, sabi ko, dissociation, yung breaking of the particles or the components of the acid to give off the charged particles. So, yung power niya to dissociate will be mababa, pero mataas yung dissociation constant nito. Ka, by the way, is the so-called dissociation constant. Okay? So please take note of that kasi tinatanong ito sa board exam. Paano nyo malalaman na the substance is a strong acid? Malalaman nyo yan, una, kung titingnan mo yung pH. Pag malaki yung pH, ayun. Now, pag mababa yung pH class, that means the acid is a strong one. Automatic yan siya. Kapag mababa din ang pKa, that means the substance is also a strong acid. Pero pag mataas yung Ka niya, si Ka lang bale yung baliktad. The more na mataas yung Ka, the more na strong ang acid. Pero later na natin pag-usapan si pKa and si Ka. Tandaan nyo lang muna itong ating way of knowing if an acid is a strong one or a weak one. Okay, ito yung mga strong ones ha, mababa na pH, mababa na pKa, pero mataas ang Ka. Okay, this is the dissociation constant. This is the power of dissociation. Okay, now, again, sinabi ko na to kanina, the dissociation class is the separation of an electrolyte to form ions of opposite charges. So when you say it separates into ions, that means you have ions that are positively charged and meron ding negatively charged. So as long as they separate and form charged particles, then dissociation ang tawag doon. Okay, wait lang ha. Meron akong kunin. Give me a minute. I know but. Wait lang. Okay, let us continue. So again, the Ka class is the acid dissociation constant. So it's like a number or a value wherein we get to see the acid dissociating. Okay, it's the point where again, our acid will dissociate. Anong meaning ng dissociation? Magse-separate siya into ions. That is what you call dissociation. So this one is an illustration of how the acid dissociates. So for example, you have this kind of acid. This one is a binary acid, just like HCl. Yun bang meron siyang hydrogen, tapos meron siyang kasamang isang element. So just like this one, hydrochloric acid. If this dissociates class, it will always give you the hydrogen ion, and itong A represents the element na kasama niya. So most likely, this element will be negatively charged. Okay? This is negatively charged. Now, how do we compute for the acid dissociation constant? This will follow class. Yung pinag-aralan natin last time, yung kino-compute natin last time na this one, equilibrium constant. Diba yung equilibrium constant natin, pag nagko-compute tayo, it's always product or products pag marami over reactant or reactants. Ganon pa rin in the computation of the acid dissociation constant. Kasi this is still under the chemical equilibrium. Naging specific lang siya. That's why instead of Ka, which is the equilibrium constant, we will use Ka. Ka, again, is the acid dissociation constant, but in the computation, you will still have this one, products over the reactant. Okay, that's how you compute, again, the acid dissociation constant. So we have here very specific example. We have the carbonic acid. So carbonic acid is H2CO3. Carbonic acid is found in our blood also, and this acts as a buffer. Pag sinabing buffer, ito yung mga substances natin na magre-resist ng changes in pH. By the way, our paki-unmute. Aaron, paki-unmute. Sino nag-mute? Okay, sige, let us continue. Again, carbonic acid gas is a substance found in our blood, and this acts as a buffer. Pag sinabing buffer, this one resists changes in pH. Okay, now our blood class, ang pH niyan is between 7.35 to 7.45. Any drastic change in the pH of our blood, pag magbaba yan siya sa 7.35 or tumaas ng 7.45, that means we have something wrong in our body. And kapag ka hindi naagapan, yung pag-change ng pH sa blood natin, pwede siyang life-threatening. Meaning, it may lead to death. Okay? So, ang tawag dyan kapag bumaba sa 7.35 yung pH ng blood natin, we call that acidosis. Ito naman, pag tumaas than 7.45, we call that alkalosis. So our body always maintains this pH range. So meron tayong buffer sa body natin, especially in our blood. Ito yung mga substances na mag-resist ng changes in pH. Kahit pa kumain ka ng acidic na food or basic na food or uminom ka ng gamot na acidic or basic, our body, our blood will always maintain this pH thanks to the presence of the buffer. Okay? Or even if you inject something in your veins, just like antibiotics. So most of our antibiotics are sample basic. So it will not really have a drastic change in the pH because of the resisting power of the buffer. So again, one example of a buffer in our blood is carbonic acid. Now, carbonic acid, syempre acid ito, it's considered an electrolyte. Therefore, in the presence of water, carbonic acid may dissociate. It will be separated into ions of opposite charges. And what are those ions? You have here hydrogen, syempre, and the opposite charge, the negative one, is the bicarbonate. Okay, so if you are going to solve for the acid dissociation constant, that's the point where our acid dissociates
Bobo, man kayo ko. Uy, bobo.
into, wala na ko. So sabi ko, again, this is the point, class, wherein our acid dissociates and separates into ions of different charges. So we have here, again, product over reactant. So ano ba yung products of dissociation ng ating carbonic acid? We have hydrogen, and then we have the bicarbonate ion. Remember, we call this bicarbonate. And sa baba, yung reactant. We only have one reactant here, and that is the carbonic acid. Yes?
Ano gani yung tawag yung dyan sa may close and open parenthesis na may AQ?
Aqueous solution. So the solution class is in its aqueous form. So liquid ito, and then 'di ba pag sinabing aqueous, the liquid is likely dissolved in water. Okay? So meron kayong makikita na mga chemical formula na may sa baba ng ng substance, example HCl, tapos may nakalagay liquid. So that is the form, the phase of matter. So liquid in its liquid form si HCl. Pag ang nakasulat naman ay G, it's gas. And then pag S, syempre solid. But this time may nakalagay na AQ, that means aqueous. Okay? Aqueous solution. Ano nga ibig sabihin ng aqueous solution? Dinefine natin ito last time. These are solutions wherein water is used as a solvent. Okay? So definitely, the carbonic acid is being dissolved in water, and so thus, the separation of the ions will happen in water also. Okay? Anything else? Do you have other questions? Wala. Sige, so let us continue. So if weak acids class are capable of dissociating, so does the weak bases. Pwede din silang mag-dissociate. Pero the dissociation is also partial. So they will react slightly with water to produce hydroxide ions. Now, for our bases, we will call the constant as Kb. So, di ba, Ke is the equilibrium constant. That's what we computed last time for the previous chapter. And then for acid, we call it acid dissociation constant, or Ka. For bases, we call it Kb, or the base dissociation constant. And this will again indicate how strong a base is. Baliktad yun siya ha, kasi si Ka, ulitin ko yung sinulat ko kanina sa screen. Si Ka also indicates how strong an acid is ha. Pero take note na malalaman natin kung strong ang acid if mababa yung pH niya, at the same time mababa yung pKa, pero mataas yung Ka. Ito yung description of a strong acid. Pagbaliktarin mo, syempre weak acid na yon. What do I mean pagbaliktarin? Pag mataas ang pH or mataas ang pKa, mababa yung Ka, ito yung weak acid. Okay? That's for the acid. Na paano naman sa ating bases? Yes, Artea?
Excuse po, ma'am. May clarification po ako, ma'am. Yung last po na example, anong tawag po doon, ma'am? Sa Ka lang po ba yun, ma'am?
Asa?
Opo, ma'am.
Kani?
Yes,
Yeah.
oo,
This
ma'am.
is for the Ka only. This is again for the Ka only. Now, for the weak bases class, we have the so-called Kb, or base dissociation constant. Pero baliktad ito, class. Kasi kailangan sa base mataas ang pH before you can say na it is a strong base. So automatic kasi yon, directly proportional kasi yan sila sa pKb. Palitan natin ha, it's not pKa anymore, it's called pKb. And then mababa yung kanyang Kb. Okay? This one is the description of a strong base. Pero most likely, we don't really use the Kb and the pKb. We always use the pH. Kasi ito yung meron tayong laboratory equipment for testing. Remember, like we have the litmus paper na mag-change ng color to indicate whether if the substance is an acid or a base. And then we have the pH meter also. Yung strips class with different colors. May 4 siyang box dyan. Different colors. And we are going to dip this in the solution. And the squares there will change color. And then, pag mag-change na siya ng color, i-check mo siya doon sa parang guide niya and see kung ano yung pH ng substance. So, meron dun siyang 0 to 14. Actually, 1 pala. 1 to 14. And then, meron talaga tayong pH tester. Ito yung machine, ito siya. Machine na merong electrode and then automatic ibibigay niya sa, para siyang like digital like this one, meron siyang digital screen here. And then if you're going to dip the electrode in the substance, talagang ibibigay niya automatically yung pH. So example, the pH is 8.1. So ito yung mga different methods of testing the pH. Okay, aside from the pH indicator. We'll talk about pH indicators also. Kasali ito sila ha. So, 4 yan. Kaya, pinakasikat among them is yung pH. Kasi again, ito yung meron tayong methods of testing. Pero all of them are used to determine whether an acid or a base is strong or weak. Okay? So, we have here an example of a weak base. We have here ammonia. Again, ammonia. NH3 is ammonia. Now, if ammonia is added in water, magdi-dissociate si ammonia and it will give you, ano nga tawag sa NH4 positive? Bida, kung naalala nyo pa, anong tawag sa NH4 positive? Positive 1.
Ammonium.
Okay, very good. This one is ammonium. O, ba't ayun na naman magsulat ng aking pen? Okay. This one is ammonium plus. Huwag kayong malito ha. This is ammonia. So aside from ammonium, it will also release hydroxide ion. So that's how an ammonia dissociates if added in water. So if you're going to compute for the base dissociation constant, this is still product over reactant. Kung nakikita niyo sa screen, you have NH4, the ammonium, and the hydroxide above. And then sa baba, you have the ammonia and water. Okay? So, definitely, ammonia is a basic substance kasi nga there is the formation of the OH pag na-dissolve siya sa tubig. Now, what do we need to study the acidity or basicity of the substance? Sa class, sa pharmacy na world or sa pharmacy na side, merong effect yung pH doon sa drugs mismo, especially sa absorption. Now, when you say absorption, this is the transfer of the drug from the administration site to the bloodstream. Ano man, ay nakuntukan. Okay, that's the meaning of absorption. So, anong ibig sabihin yan? For example, masakit ang ulo mo. Ano yung mostly iniinom natin pag masakit ang ulo natin? Mostly, ha? Ha?
Medical.
Medical yun yung ginainom?
Paracetamol.
Paracetamol, okay. Sige, medical is a brand name, ha? But let us have paracetamol. So this one is the most common. The most likely, paracetamol is in its tablet form. Okay? Remember, masakit yung ulo natin, ha? So since this is in its tablet form, we are going to administer this orally. Now, pag in-administer natin ito orally, so syempre, saan siya pupunta? Sa gastrointestinal tract. So, dadaan siya sa esophagus and then sa stomach and then the intestine. Now, along the way, mag-undergo ito ng disintegration and dissolution. When I say disintegration, syempre magbe-breakdown ang tablet. Lisod po kung giinom nimo siya as tablet, ilibang po nimo siya tablet. No, lisod kayo na siya. So again, along the way as it passes through the stomach or the gastrointestinal tract, nagbe-breakdown ang tablet. We call that disintegration. Tapos, madidissolve yan siya sa liquid na nasa gastrointestinal tract natin. We call that dissolution. So, itong disintegration process, breaking down yan ha, and then pag mag-breakdown na siya, madidissolve siya. So, we call that dissolution. This is part of the liberation process. What do you mean by liberation process? It's the process of releasing the active ingredient of the drug. So itong paracetamol tablet, nabuo yung tablet na yan, pero hindi yan lahat paracetamol. So pag sinabing 500 mg paracetamol, 500 mg lang nito ang paracetamol. Other components are called pharmaceutical excipients. Okay? Kasi kung 500 mg lang, masyadong maliit yon, hindi mabubuo yung tablet. So, kailangan natin ng other substance na pandagdag dyan para mabuo yung tablet natin. So, para magkaroon yung effect, kailangan ma-release natin yung active ingredient. In this case, that is paracetamol. Pag na-release na yan through these processes, magkakaroon ng absorption. Okay? From the site of administration, meaning from the gastrointestinal tract, that the active ingredient, the drug, will be transferred to the bloodstream. Okay? Pag nasa blood na yung gamot, class, that's the time it will be distributed all over the body kasi syempre nag-circulate yung ating dugo. Now, pag ang drug umabot doon sa target site, that's the time magkakaroon siya ng effect. Okay? That's how your paracetamol treats your headache. Ininom mo siya orally, pero magkakaroon siya ng effect sa ulo mo. Pero it doesn't mean, class, na masakit yung ulo mo, dun lang talaga pupunta ang paracetamol. No, if you drink a drug, if you administer a drug, all over your body merong gamot. Kasi ang gamot nasa blood natin and yung blood natin is nag-circulate. So kahit sa paa mo may paracetamol, ganun yun siya. So kung ano yung umabot doon sa target site or sa ulo mo, in this case kasi masakit nga ang ulo, ayun lang yung magkakaroon ng effect. Now, this process is actually complicated. May mga bagay na kailangan natin bigyan ng pansin para masiguro natin na magkakaroon talaga ng effect yung drug. So isa na dyan yung absorption. Kasi hindi basta-bastang natatransfer ang drug from the gastrointestinal tract to the bloodstream. Okay? Hindi yun siya basta-basta. Kailangan meron tayong mga i-consider for a drug to be absorbed. So isa na dyan, class, yung pH. Si pH, meron yan siyang effect on drug absorption. Now, anong effect niya on drug absorption? Most of our drugs, class, are either weak acids or weak bases. And hindi may mga form ito sila, class, na hindi basta-basta na-absorb. Remember, pag ang drug is acidic, 'di ba? Pag na-dissolve ito siya sa water, remember may water sa body natin. And then sinulat ko kanina, before ma-release yung ating active ingredient, yung ating drug mismo, kailangan ma-dissolve siya. Okay? So pag na-dissolve siya, syempre sa water, mag-a-ionize yung drug natin kasi acid nga or base. So for an acid, pag nag-ionize siya, 'di ba, magpo-produce siya ng H+ and please correct this one, this is a negative. Okay? I-correct niyo lang muna yan siya. Now, for an acid, the drug passes through membranes more readily if it is uncharged. Thus, for a weak acid, the uncharged HA can permeate through membranes and A+ cannot. So ano daw ang ibig sabihin nito? 'Di ba? You have the acid here. Pag ma-dissolve yan siya, ano daw sabi? Mag-dissociate yan siya into this one, H+ and A negative. Ang problema natin, class, with an acidic drug, pag nag-dissociate siya, this one cannot cross membranes. Hindi siya makakross sa membranes. Remember, from gastrointestinal tract, our target is pupunta ang drug sa blood. And paano siya pupunta sa blood? Kailangan niyang makakross sa lahat ng membranes na nandyan sa gastrointestinal tract mo and sa blood vessels. So again, ang dissociated form ng acidic drug cannot cross the membranes. Ano daw yung makakross? Yung hindi nag-dissociate. Itong HA na ito. So, pag gumawa tayo ng drug class, kailangan i-make sure natin na pag acidic drug siya, hindi siya mag-ionize inside the body. Kasi again, pag nag-ionize siya sa gastrointestinal tract, hindi yan siya ma-absorb. Anong mangyayari pag hindi ma-absorb yung ating drug? Walang effect. Okay? Again, isulat ko talaga yan. Pag hindi ma-absorb ang drug, walang effect talaga yon. Okay? Kasi it will be the blood that is responsible to distribute the drug all over the body. Pag hindi yan siya nakakross ng membrane, magsistay yan siya sa gastrointestinal tract natin and ang ending yan is excretion. It's either iihi mo lang siya or ma-incorporate siya sa stool natin. Okay? So again, pag gumawa ng drug ang isang pharmacist or ang isang chemist, if nakita niya, oh, the drug is a weak acid, magde-design siya ngayon na itong weak acid na ito will remain uncharged and will not dissociate inside the gastrointestinal tract. Okay? So, paano yan siya ginagawa ng mga pharmacist and chemist just to make sure na ma-absorb yung acidic drug natin? Ginagawa nila ito. Salt. I don't know if I have mentioned this sa inyo last time. Parang may nagtanong ata, di ba, na yung drug is merong HCl, yung iba merong sodium, potassium, ganon. Let me give you an example, pero I just don't know if you are familiar with this. Meron tayong drug na sodium. Na-mention ko. I'm gonna mention ko ito. Ulitin ko. It's not it. Okay. Diclofenac NA. Again, I just don't know if you're familiar with this drug. This one is an NSAID, a non-steroidal anti-inflammatory drug. So, asan siya ginagamit? Mostly makikita nyo ito sa mga persons like merong arthritis, kasi nga this is an anti-inflammatory drug. Now, itong diclofenac is a weak acid. Kung titingnan natin sa kanyang chemical structure, meron yan siyang acetic acid. Kaya yan siya nag-end sa AC kasi acetic acid derivative ito. Now, syempre weak acid siya. Diba sabi ko, hindi dapat siya mag-ionize inside the body. So, ang ginagawa nila, nilalagyan nila ng salt. Nilalagyan nila ng sodium. Yan ang purpose ng sodium dyan. Para pag punta sa GIT nitong drug na ito, hindi pa muna maghihiwalay si diclofenac. Magiging diclofenac plus sodium pa muna siya. Okay? So since hindi nag-ionize si diclofenac, it can cross the membrane and magkakaroon siya ng effect. So may mga purpose class yung mga dugtong-dugtong dyan sa gamot natin. This one is an example. Okay? So para hindi muna mag-dissociate si diclofenac, nilalagyan siya ng sodium. So inside the gastrointestinal tract, meron kang diclofenac plus sodium muna. Again, makakross yan siya ng blood-brain barrier. Ay, blood-brain barrier. Sorry, the membrane pala. Yeah, same concept with that of the HCl sa dulo. Example, this one. Pero this one is a basic drug kasi. Basic drug. Phenylephrine HCl. So si phenylephrine is a component of our Neozep. Kung namoy Neozep din tanawan ninyo. Tatlo kasi ang component ng ating nasal decongestants mostly. Neozep, Decolgen, Bioflu. Ayan, component yan siya. Phenylephrine is one of the active ingredient. Kasi meron pa yan siyang other component, chlorphenamine, maleate, and paracetamol. Tatlo ang component ng ating Neozep, Decolgen, and Bioflu. So kung titingnan natin si phenylephrine HCl, meron siyang dagdag na hydrochloric acid. This one is a basic substance. So, acid yung kanyang partner to make it a salt para mas madali siyang ma-dissolve. I-discuss ka na siya later. Yan ay HCl, yung phenylephrine. So, para saan yung Neozep, Decolgen, and Bioflu? Para saan nga yan? This one, these are all OTC drugs, over-the-counter drug. Saan yun ginagamit yan? Uminom kayo niyan? Neozep, Decolgen, or Bioflu? Well, let me check kung tama inyong pag-inom, ani. Ang uban, wala ga-inom. Nasal decongestant. Neozep lang, ma'am. Inigsip ko nun. As in? Grabe duha. Bioflu paglagnat. Most of the drugs will be after meals. Okay? After na siya magkaon. Kasi most of the drug requires food for absorption. Class, walay tambal sa sipon ha. I want to clarify this one. Number one, wala tay tambal sa colds, wala tayong gamot sa sipon. Bakit? The cause of colds or sipon class is virus. Okay? Virus ang nagkokos niyan. Ang problema natin, ang problema natin, murag mga 1,000,000 nga klaseng virus ang pwedeng mag-cause ng sipon. Now, our problem with virus class, pag tinreat natin si virus, pag gusto nating patayin si virus, the drug should be specific. Okay? The drug should be specific. Now, kung 1,000,000 ang naga-cause og sipon class, it will be very impractical for us to determine unsang klaseng virus ang nag-cause sa imuhang sipon. Nakuha nyo? It will be very impractical para isa-isahon nato nga karong adlaw ang nag-cause sa imong sipon kay ani nga virus. Pagkasunod nga week, nagsipon na sad ka, magpa-doktor na sad ka, kay ipa-check na sad nato unsang klaseng virus na sad ang nag-cause sa imuhang sipon. Okay? Kay kailangan man nato specific nga drug. So mao na siya ang reason why until now wala tayong gamot for sipon. Okay? wala jud tay drug for sipon. It's very impractical nga magsige kag pa-check up every time nga magsipon ka just to determine what causes the cold. Okay, just to determine kung ano yung gamot na ibibigay. So marami tayong antiviral drugs sa market. Ang problema natin yung pag-determine ng cause ng sipon mo. So yung Neozep, Decolgen, and Bioflu are not really drugs for colds. What are these drugs? These are nasal decongestants. What does it mean? This will only treat symptoms of cold. So symptoms lang, hindi talaga siya yung drug na papatay sa virus na nag-cause ng sipon mo. Ang ititreat lang ng drugs na ito yung symptoms. Kasi pag nagsipon ka, most likely you will have clogged nose. Mahihirapan kang huminga. We call that clogged nose or congestion. So to relieve the congestion, we give nasal decongestant para makaginhawa kag tarong. Muna siya ang ginatreat sa Neozep, sa Decolgen, o sa Bioflu. I really want to correct the misconception about these drugs. Okay, nasabtan to. Kinsa wala kasabot, katong uliton.
Pardon, ma'am.
Again, class, wala tayong drug for colds ha, for sipon. Kasi ang cause ng sipon ay virus. Kaya lang masyadong maraming types of virus ang pwedeng mag-cause ng sipon. Now, ang tandaan nyo, class, pag virus, kailangan kasi specific ang gamot. Kasi hindi yan sila magkakapareho ng characteristics. So kung kailangan natin silang patayin, dapat specific din yung drug for that virus alone. So murag impractical, class, na magsige tagpa-check up every time ta magsipon, and impractical kaayon na ipadetermine yun na to pirmi ang cause sa ato ang sipon. So ang ending, hindi talaga gumawa ng drug para sa sipon, class. Ang ginawa lang na drug is for the treatment of the symptoms of cold. Kaya diba pag nagsisipon ka, you will definitely have clogged nose or nasal congestion. So mahihirapan kang huminga. Yun lang yung ititreat ng gamot, the phenylephrine. Yun lang ang ititreat niya. There will be nasal decongestion para makaginhawa ka. O na siya ang trabaho ni phenylephrine. Pero pag pangutanon ko ninyo kung napatay ba ang virus for this, no. Hindi siya namamatay for this. Talagang i-decongest niya lang yung ilong mo para makaginhawa kag tarong pag ginasipon ka. Okay? So that is the work of phenylephrine. Phenylephrine is a nasal decongestant. Basig mangutan na mo para asa ang chlorpheniramine maliit, ma'am. Kabalo man mo para asa ang paracetamol, no? Paracetamol is a pain reliever and antipyretic. Pag sinabing antipyretic, that is to reduce your body temperature. So para sa lagnat. Kasi most of the time no, pag ginalagnat ka, ginasipon sad ka mo, nagi-partner na silang duha. And then chlorphenamine maleate is antihistamine. Ang ibig sabihin pag antihistamine, this is for allergy. So mo na siya, class, nga pag mo inom kag Neozep, Decolgen, and Bioflu, katulugon ka. Kay naa siya content nga anti-allergy. So maupod na ang ginaingon nga na ay Neozep non-drowse. Are you familiar with this? May nakalagay Newzep non-drowse. Pag dili ka
Opo,
gusto,
ma'am.
pag dili ka gusto makatulog, kani imuhang paliton. Kay nga naman gitanggal nila ni. Wala siya anti-allergy na content. Now, dili ibig sabihin class nga Newzep para sa gisip-on, Bioflow para sa gilagnat. Dili na siya mao, parehas lang na sila tanan og content, meaning parehas lang na sila tanan og activity inside the body. Kay basig ang inyong gihimo, gilagnat ko mo inom kog Bioflow. Tapos gisip-on pa jud ko mo inom kog Newzep. Dili ha, nagdubli-dubli ang tambal sa inyong lawas. Parehas lang na
Madoble
sila.
ang dose.
Yeah, na doble jud ang dose. Kasi parehas lang sila ng content. So parehas lang sila ng activity. Na mali lang na siya class tungod sa ilahang advertisement. Kaya advertisement man gud sa Newzep para siya sa sip-on. Tapos ang advertisement sa Bioflow para siya sa trangkaso. Pero actually parehas lang na silang activity. And kaning Newzep ug Bioflow parehas lang na nga company ang nagbuhat sa ilaha, di ba? Kuyo kay silang marketing strategy. So parehas lang na sila nga Unilab. So kung gisipon kayo class or merong trangkaso, isa lang ha, isa lang. Pamili ka na lang dyan. Either Newzep, Decolgen, or Bioflow. Ayun, i-dubli-dubli di mo gustong ma-overdose. And remember, by the way, phenylephrine can cause hemorrhagic stroke. Kung dili ka gusto ma-stroke din ha sa imong giinom nga tambal kay nagdoble-doble. Please correct this one ha. Ikaw mismo and even your family members, if they have like problems with how they think or what they think about these drugs, please correct them. Okay? Need na mag-Newzep plus Biogesic? No! Kapag uminom ka na ng Newzep, huwag ka nang uminom ng Biogesic kasi Newzep itself contains paracetamol. So pag uminom ka ng Biogesic, nagdoble na imuhang paracetamol class. Alcohol. Patay sad ka. Plus yung mga bata pa nag-start inom-inom na, please have your liver checked. Kay basig ang imuhang utok kusog kaayo mo inom pero imuhang liver di ay wala na nakakaya din ha. Okay? Naawa na ninyo basig nag-awas na ang enzymes ninyo sa liver. Kasi pag manginginom ka class, wala ka talagang like pain na mararamdaman in your body. Pag nasira yung liver mo, hindi kasi yan siya yung sasakit yung tiyan mo always, no. Hindi. Wala kang mafe-feel. Magpapacheck ka na lang, nag-aawas na dahil imuhang liver enzymes. Wala kang mafe-feel na sakit hanggang hindi yan siya magiging terminal. So be careful with like drinking alcohol. Basig utok lang ang kusgan imuhang liver dili. Yeah, wrong. Wrong dyan na siyang Biogesic for lagnat tapos sabayan og Newzep for sipon. Pag Newzep lang. Kung gilagnat lang ka, wala kay sipon, Biogesic lang. Grabe, Biogesic jud no, gina-advertise gyud nato ang ilahang brand names. So when I discuss drugs, you seldom hear me talking about brands kasi marami tayong masyadong brands in the market. Like I'll just call it paracetamol because that's the true name of the drug. That's the chemical name. So paracetamol. Pero pag may kasama kasing sipon, that's the time you take nasal decongestants like Newzep, Decolgen, or Bioflow. Okay? 2 weeks na ka ginasipon, di mo wala. Hindi kasi talaga nawawala yung sipon if you take Newzep. It will just help you unclog your nose para dili ka malisdan mo ginhawa. I hope na sabta na siya. Okay? Magsuka jud na siya, class. Please take note of this. Ako isulat sa screen. The difference between a drug and a poison is the dose. Please take note of that. The difference between a drug and a poison is the dose. So if correct dose yan siya, it means it's beneficial in the body. It's a drug. But pag nagsobra-sobra na inyuhang dose, that's the time the drug becomes a poison. Okay? I know someone class, tung college ako, syempre marami akong friends sa Davao. I have this friend na nagpakamatay siya kay gibulagan siya sa iyang uyab. Tapos paano siya nagpakamatay? Niinom siya og duha ka pad nga biogesic og isa ka pad nga alaksan. Samo kayo way magpakamatay. Giinom jud niya as in gilaklak niya ang paracetamol, ang biogesic ug ang alaksan. So namatay siya, wala siya namatay. Kay pagkahuman niyang inom ni sakit man iyang tiyan. Pag sakit sa iyang tiyan, nagpadala siya sa ospital. Therefore, wala siya namatay. Sa mukha jud sawo kayo to. Anyway, that's it. It becomes a poison kasi sobra-sobra na. Paracetamol class is a safe drug. Pero pag nasobraan ka ng inom, that's the time it becomes a poison. The number one target ng paracetamol inside the body is the liver. So it's most likely the gastrointestinal tract mo na nga magsukag yung ka if masubraan ka og drugs. Yeah. Mo na siya na I'm not really into like very expensive brands of drugs kasi kasama sa binabayaran mo yung kanilang marketing, yung kanilang artista parehas kay John Lloyd. Ingat, 'di ba? Sikat kayo, sikat kayo ang biogesic. During the pandemic, 'di ba, there was a time na nag-viral sa social media na nagkakaubusan ng paracetamol. Actually, that is true. Nagkakaubusan talaga yun ng paracetamol, ay ng biogesic only, ng biogesic. Pero it does not mean na wala ng paracetamol sa market. Biogesic lang yung naubos. Hindi na makakaya yung production nila sa demand. So grabe ilahang marketing strategy no kay pag moingon kag paracetamol biogesic dayon. Daghan pag klaseng paracetamol sa market. So kung wala na biogesic, pwede paghihapon mo palit og paracetamol. Ingna lang pharmacy din ha kung unsang ilahang paracetamol na available. Pag may sipon, pag may sipon ako, I drink water. Matablan na yun nagtubig tanan. Okay, that's the irony of being a pharmacist. Again, the irony of being a pharmacist, hindi mo inumog tambal. So, pag pangutanon ko niyo, ma'am, si tambal sa ano? Ako diyang tubag, anak, pero sa inyo tubig. Water therapy. Tubig lang na din. Okay, inom mo daghang tubig pag ginasipan mo. If clogged in yung nose, malisdan mo ginhawa ka ng malisdan na yun, that's the time you may drink nasal decongestants. Yeah, effective ilahang marketing strategy. Yeah, water therapy is actually effective. Class, pag nagsakit mo, give yourself a time to heal. Kaya ng sarili natin mag-heal ng sariling body natin. Okay? Kasi pulo sa atong immune system din ha, ato ang mga antibodies, atong mga white blood cells inside kung dili nato na sila patrabahoon. Do not be too dependent sa drugs. Okay? So give yourself a time to heal. O bito na ako manghudinhi, nag-diarrhea siya. Nangutan na siya sa kuha, nabadaw ko yung loperamide. ano ko paghulat og 24 hours kay tagaan ta ka og loperamide. Nautan kino. After 24 hours ko pa siya binigyan ng loperamide. Kasi pag nag-diarrhea ka, ilabas mo yan lahat, class. Kasi nga nag-diarrhea ka kay may toxin inside. May something wrong, may bacteria dyan, may toxin dyan inside. So kung wala ka namang lakad, kung nasa bahay ka lang naman, ilabas mo yan lahat, okay? Just make sure to replenish the electrolytes. So I did not give him loperamide, pero uminom siya ng electrolyte replenisher. Walang hydrate kasi so nag-stick into Gatorade. And then after 24 hours, pag hindi pa rin nag-stop yung diarrhea, that's the time you administer loperamide. Universal yacht. Water is actually effective. Dahon ng atis ilagay sa ilan. Oh, I don't know. I heard it this time only. First time kong narinig yan. Makahuganan. Yeah, soldiers in the body. That's the white blood cells. Okay. So, class, ayun. We are studying drugs here, pero do not give in to drugs right after na magsakit kayo, no? First day pa lang sa inyong sakit na inom na dahil tambal. Tagay po ninyong time inyong sarili mag-heal. Uy, galaw-galaw dyan, white blood cells. Ako pag masakit ang ulo ko, tinutulog ko yan siya. Inom daghan tubig tapos tulog. Pag kaya pa nako. Pag dili na nako kaya, ang akong dili kaya manggod ang akong migraine. I have my optical migraine. I'm very sensitive to light. So, and syempre yung sa pulaw. Pero kinakaya ko yung migraine ko pag wala akong ginagawa. Pero pag may gagawin ako, just like this one, nagdi-discuss, tapos nag-migraine, that's the time I drink drugs for migraine. Minsan paracetamol lang, minsan Saridon. Pag kanang dili na gyud nako kaya, I need a stronger one. So I need Saridon. Saridon is a brand. Tinuod. Calamansi and other citrus fruits are rich in vitamin C. So it's just like taking vitamin C, no? Yeah, it can boost your immune system. That's the rationale of like taking citrus fruits when you are sick. It can give you additional vitamin C in the body, and it can boost your immune system. That's the rationale of drinking calamansi pag ginaubo. Okay, so any question? Wala? So how about the weak bases class? Ang weak bases kasi it's protonated na in its original form. So if it dissociates, it will give us the B plus H plus. Itong B yung product niya. Ito yung na-absorb in the body. So this time naman, baliktad sila sa acid. Sa acid kasi pinipigilan nating mag-dissociate ang acid para ma-absorb siya. Sa bases, kailangan ng base talaga mag-dissociate para mag-absorb siya. Kasi yung form ng base na nag-dissociate ay na ma-absorb is yung dissociated form niya. Kasi pag charged ang particles class, walang absorption na mangyayari. Hindi siya makakross ng membrane. So please take note of that ha. Pag acid, pag gumawa tayo ng drug, kailangan hindi siya mag-dissociate. Pero pag si base, kailangan siyang mag-dissociate. Kasi yun yung ma-absorb. The caffeine class is caffeine has pain relieving activity in the body. So like Saridon contains caffeine. So yan yung iniinom ko pag masakit ang ulo ko. chlorphenamine class is an antihistamine, and most of our antihistamines can induce sleep. They are sedative. So, pag uminom kayo ng yung hindi non-drowse na Neozep and Decogen and even Bioflu, it can really sedate you. So be careful with those drugs also. So ito yung sinasabi ko kanina, the uncharged form ng base natin, yung makakross ng membrane. So yan yung ma-absorb. But the original form of the basic substance is actually protonated. So it will be difficult. So kailangan for a basic drug, kailangan mag-dissociate talaga. Yeah, the side effect. The sleep-inducing activity of antihistamines is side effect niya yon. Pero the main activity is to counter the allergy. So most of the antihistamines can really induce sleep except for loratadine and fexofenadine. I'm not sure if you're familiar with fexofenadine, but I believe you are familiar with loratadine. Yan yung hindi nakakatulog na antihistamine. So kung nag-allergic kayo and then you don't want to sleep, like meron pa kayong maraming gagawin, you may take the loratadine. Do not take cetirizine or diphenhydramine. Do not take those kasi they are notorious of inducing sleep. Okay? Well, any other question? Before tayo mag-move on with the ionization of water. Kasi water class is also considered an electrolyte. So kaya pag uminom ka ng energy drink, hindi lang sodium, chloride, magnesium, potassium, hindi lang yun ang electrolyte. Water itself class is an electrolyte. Therefore, si water is nag-ionize din or nagdi-dissociate din. So kaya kasali sa discussion natin, aside from acids and bases, si water. Okay? So again, how water is also considered an electrolyte. And therefore, water also has the ability to conduct electricity. So, makanang makuryente ka na ay water. Water has an ability to conduct electricity. How much more kung may additional siya na mga ions. Okay? Kaya, di ba, merong experiment sa science when you were in high school, yun ngang magpailaw kayo ng bulb. Tapos yung, I don't know if you have done that in your high school days. Yung gagawa kayo ng circuit, tapos may bulb. Tapos yung electrode sa end is ididip lang siya sa water na may asin, tapos iilaw yung bulb. Di ba may ganyang experiment? Now, that is true. Kasi again, water na may salt. Kasi water class, number 1 is an electrolyte. Pwede siyang mag-dissociate into ions, charges. Tapos may salt pa talaga, which is also an electrolyte, na in the water, mag-dissociate din, magre-release din ng ions. Magkakandak talaga yan ng electricity. Okay? Sa Vita Plus na try. Those are just the work of the ions in water and all the other ingredients na electrolytes din. Magkakandak talaga yan siya ng electricity. Not endorsed. Ano siya? Disclaimer. We are not endorsing any product here. Okay. Pero yan yung explanation niya. Now, class, please take note of this since this is also a board exam question. Water is the most amphoteric substance. In theory, yes. Gatorade can also do that. Because remember, aside from water, Gatorade has a lot of electrolytes. Si sodium, si chloride, si magnesium, andyan yan siya lahat sa Gatorade. So in theory, yes, it can light up the bulb also. So again, most amphoteric substance natin si water. When you say amphoteric, if you hear this word amphoteric, okay, it means the substance can act as either an acid or a base. So si tubig glass, ang tubig na iniinom natin, pwede siyang acid, pwede din siyang base. Ang tawag dyan, amphoteric. Okay? Kasi si tubig glass, pag kurap sa tawag. Sa mukay. Again, pag ang tubig glass, pwede siyang mag-act as acid kung ilalagay mo siya, ipapareact mo siya sa basic substance. Magiging acid siya. Pero pag ang ipapareact mo siya sa acid na substance, si water ay magiging base. So depende yun siya sa reacting substance class kung ano mag-a-adjust ang water. Okay? So pwede siya again, acid or base. So again, mag-a-ionize din ang tubig natin. So magpo-produce din siya ng ions. Okay? So this time, this involves the transfer of a proton from one water molecule to another to produce the hydroxide and hydronium ion. Paano kung water? Water lang talaga, maraming water molecules. Mag-ionize pa rin yon pero magre-react lang siya with sa kapwa niya water. So meaning, water plus water will have a reaction. Okay, anong sabi dyan? Transfer siya ng proton. Ang proton nito itatransfer sa kabila. And when I say proton, I'm talking about hydrogen. So ang ending niyan, you will have this one. This is called the hydronium ion. Tapos, kung nabawasan ng isang hydrogen ito, meaning OH na lang yung natira. So ito yung magiging products ng ionization of water. Hydronium ion and hydroxide ion. That's how the water ionize. Pag H plus lang class, hydrogen ion lang talaga yun ha. Pero pag H3O plus, which means water yung talagang nag-ionize, hydronium ang tawag dito. Okay? So ito yun. Ito na yung sinulat ko kanina. H2O plus H2O will give you hydroxide and hydronium ion. So if you're going to compute for the equilibrium constant of this, di ba equilibrium constant is product over reactant. So ayan. This is our equation. But for ionization of water, this one, water ionization constant. Kw is water ionization constant. Ito lang yung magiging formula natin. Tatanggalin natin yung reactant sa baba. Products lang yung kailangan natin for the water ionization constant. So that will be concentration of the hydronium ion times the concentration of the hydroxide ion. Yan lang. Ito lang yung kailangan natin again for the ionization, water ionization constant. Formula, oo, formula. Okay. Sige. So, according to the experiments of scientist class, yung water supposedly at 25 degrees Celsius, actually pantay yung concentration ng H plus and ng OH plus. H plus can be your hydronium ion ha, baka malito kayo. Okay? Again, experiment shows at 25 degrees Celsius, yung concentration ni hydronium ion and ni hydroxide ion is the same. It's 1.0 times 10 raised to the power of -7 molar. Pareha sila. Ito, hydronium ion is this one, 1.0 times 10 raised to the power of -7. And then the hydroxide ion is also 1.0 times 10 raised to the power of -7. Therefore, if we are going to compute for the water ionization constant, diba ano nga yung formula nun? H3O plus times OH negative. Ang water ionization constant class is this one. So, i-multiply nyo yan siya. 1.0 times 10 raised to the power of negative 7 times 1.0 times 10 raised to the power of negative 7. I-check nyo with your calculator. You will get the 1.0 times 10 raised to the power of negative 14. Ito yung water ionization constant. Yan talaga ang constant. It's the time wherein our water will ionize. Okay? Based on concentration. Yan yung time na mag-ionize yung tubig natin. When it reaches this constant. Okay, questions or clarifications? Wala. Let me check. Okay, nag-chat si Ma'am Cherry. Okay, I cannot give you another example for this kasi this is for water only. Walang ibang computation ito. Ito lang talaga ang sa tubig. So, pag water lang ang pinag-uusapan natin, again, pag tubig lang yung pinag-uusapan natin, ito talaga yon. Ito yung kanyang concentration sa hydronium. Ito din yung concentration niya for OH. So, wala siyang ibang constant. Ito lang. 1.0 times 10 raised to the power of negative 14. Wait lang, class, ha? Basahin ko lang ang memo ni Dean. Tomorrow? Oh my gosh. Oh. Okay. Asynchronous kasi pala bukas, no? Sa hapon. Ay, wala na sa klase. Tapos next week, Teacher's Day. Tapos pagkasunod na week, intramurals. Tapos pagkasunod na week, exam na. So, unsa atong exam? Wala kay klase-klase, tabang, mga langit. Class, kung tong high school mo ganahan mo walay klase no sa college kay wala gid ako na siya na feel tong maestra na ko sa college di ko ganahan og walay klase kay ngano kung sige na lang og walay klase sa ko exam like tabang anyway wala ko mabuhat ana okay sige let us discuss the importance na lang of water ionization constant. Itong water ionization constant, magiging magiging reference doon sa acidity and basicity of other substance. Kasi pag sinabi mong water, that's the time it's neutral. Kasi pantay yung amount of hydrogen ion and yung hydroxide ion. So basically, it's neutral. Okay? Kaya yung pH natin is actually 1 to 14. Dito yan siya naka-base. Okay? So kung pantay yan, nasa 7, di ba? Neutral. Sinulat ko ito kanina. Ito yung substance na neutral. So ito yung naging reference nung system na yon na ginagamit natin in determining whether a substance is acidic or basic. So paano kung tumaas ang H+, class, hindi na, example, hindi na siya pantay kasi dapat 'di ba pantay sila at 1.0 at 10 to negative 7 para neutral yung substance natin. Pero yung mga instances na there are other substance na mas mataas yung H+ nila, automatic mababa talaga yung hydroxide ion nila. Okay? Kasi always hanggang 14 lang talaga yan siya. 1 times 10 raised to the power of negative 14. Hanggang 14 lang siya. So kung tumaas ito, talagang bababa ito. Kasi wala tayong ibang total. It's this one only. Okay? So this one yung kanyang illustration. Para mas maintindihan na ako kasi nito masyadong maraming words. Ito yung kanyang illustration class. A neutral solution class daw is pantay yung concentration ng hydrogen ion and then yung hydroxide ion. So kagaya sa case ng water kanina. Pero matatawag mo siyang acidic pag mas mataas yung concentration ng kanyang hydrogen ion compared to the hydroxide ion. So remember, this is greater than. So H plus is greater than OH negative. And then, ito, basic solution, kapag mas mababa yung concentration ng H plus, mas mataas yung concentration ng hydroxide ion. So it's the other way around for the basic solution. Please remember this. Pag mataas ang H plus acidic, pag mataas ang OH basic. Okay? So meron itong calculation. But before tayo mag-problem solving, mag-calculate, mag-break muna tayo, water break and CR break. Tapos manghunat ta sa ito ang calculation. Okay? Pero hindi yan siya mahirap na calculation. Yes?
Excuse, ma'am, pwede pakibalik doon sa isang slide kanina, ma'am.
This one?
Yes, ma'am. Ay, kadyat lang.
Okay, sige. Anyway, mag-break muna tayo. Tapos mag-computation. Okay? Be back after 5 minutes. Okay, so this is for the calculation of hydrogen ion or hydroxide ion for solutions at 25 degrees Celsius. And then after the computation, we have to determine whether the substance is neutral, acidic, or basic. So let us have the first example. Ganito class ha. Ito yung given. Okay, 1.0 times 10 raised to the power of negative 5 molar hydroxide. Pag hydroxide ang given class, ang hahanapin is gaano karami ang hydrogen ion. And what will be our formula? Our formula is the Kw is equal to H plus times the hydroxide ion. Okay, remember class, H plus can also be hydronium ion ha. So baka minsan yung ibibigay hydronium ion. So it's similar. Okay, now take note class that Kw is always 1.0 times 10 raised to the power of negative 14. This is constant. Okay, constant yan siya ha. So yan yung always hahanapin natin. Yan yung always gagamitin natin. So pag ang given is OH, syempre again, ang hahanapin is the hydrogen ion. So ano ang given dito? 1.0 times 10 raised to the power of negative 5. So sinubstitute ko lang yan ha. Again, I substituted this one. So what will be the next step? For us to compute the concentration, for the concentration of hydrogen ion. Ang gagawin?
I-divide both sides sa 1.0 times 10, ma'am.
Okay,
Tama.
sige. Divide both sides by 1.0 times 10 raised to the power of negative 5 para makancel siya dyan, maiwan yung hydrogen ion. Okay? So what is the answer for this? Ilagay ko sa baba ha kasi wala na akong space. H plus is equal to, there's my calculator. Sino yung calculator ko? Wala. Sige, what's the answer there? 1.0 times 10 raised to the power of negative 14 divided by 1.0 times 10 raised to the power of negative 5. What's the answer? 1.0 times 10 raised to the power of negative 9. Ito daw yung concentration of the hydrogen ion. So ito ng computation, hindi talaga ito mahirap, no? I-divide lang talaga natin. Just look at the given. If OH ang given, syempre H plus ang hinahanap. Pag H plus ang given, syempre the other way around. OH yung hahanapin. Now, ito daw yung concentration ng hydrogen ion, ito naman ang ng hydroxide ion, and then ito naman ang concentration ng hydrogen ion. So ang next question, if these are the concentrations of the two, is the solution neutral, acidic, or basic? Paano natin yun malalaman? Ano nga sabi kanina sa rule natin? Pag equal daw ang H plus and OH negative, neutral. Siyempre silang dalawa ay hindi equal. So, titingnan natin ngayon. If H plus is greater than OH negative, the substance or the solution is acidic. But if it's the other way around, the OH is greater than the H plus, this will be basic. So how are we going to evaluate this? Acidic ba siya, basic, or neutral? Ano ba mas malaki? Ang OH or ang H plus? Saan ang mas malaki dyan sa kanila? OH or H plus? Siyempre ang
OH, ma'am.
the OH. The OH yung mas malaki dyan, class. So therefore, the substance is basic. Okay, bakit mas malaki yung OH? Class negative ito ha. Pag ang exponent class negative, kapag malaki yung value, yung number na kasama ng negative, bababa yung kanyang value. Okay? Naka-scientific notation kasi yan siya. Ano ibig sabihin yan? Pag naka-scientific notation, di ba i-move mo yan siya? Kung negative 5 yung kanyang exponent, di ba i-move mo yan siya to the left ng 5 beses. So 1, 2, 3, 4, 5. Dito yung decimal. So 0.0010. So compared to 1.09. So ka-9 mo din siya i-move. 1, 2, 3, 4, 5, 6, 7, 8, 9. So nandito ang decimal. Lagyan mo lahat ng 0 dyan. So syempre kung titingnan nyo, mas malaki talaga ito. 'Di ba? Konti lang yung 0 niya. Ito marami masyadong 0. So please take note ha. Pag naka-scientific notation, pag negative ang exponent, the larger the number, the lesser the value. So, comparing negative 5 and negative 9 for these scientific notations, mas malaki ang value nito. Okay, so since malaki ang value niya, basic siya. Naintindihan? Naintindihan yun. May questions ba? How about the next one? The next solution. 10 talaga yan siya, though it's not a correct scientific notation, but for the sake of just the computation, 10 talaga yan siya sa letter B. Can I erase the writings on the screen now? Anyway, this one is being recorded. Now you may review this one. So it's the same thing, the same formula. Kw is equal to H plus times OH negative. And Kw is the same, 1.0 times 10 raised to the power of negative 14. And then, ano ang given? OH pa rin, no? So H plus pa rin yung hahanapin natin. Times the given, 10 times 10 raised to the power of negative 7. So this same process, divide both sides by this one to isolate the H plus. So what's the answer for this one? Sige daw. Oo, pag nakalagay sa given ay OH, ang hahanapin mo ay H. So pag H din ang given, OH ang hahanapin. Sige daw, i-divide natin 10 times 10 raised to the power of negative 14 divided by, 10 times 10. 1.0 times 10 raised to the power of negative 14 divided by 10 times 10 raised to the power of negative 7. The answer is 1.0 times 10 raised to the power of negative 8. Okay, 1. Ano nangyari dyan? May mali ba sa computation ko? 1.0 times 10 raised to the power of negative 14 divided by 10 times 10 raised to the power of negative 7. 1 times 10 raised to the power of negative 8. Tingnan ko ano, 1.8 yung answer. 1.0 times 10 raised to the power of negative 8. Okay, so this is the H plus. So next question, acidic or basic? Okay, itong 10 times 10 raised to the power of negative 7, mali ito na scientific notation ha. Bakit mali yan? Kasi 'di ba pag scientific notation, the base number here should just be 1 to 9. So mali ito. Then kailangan natin to siyang iayusin. So 'di ba 10 nandito. So 1 2 3 4 5 6 7. Ito yung original number niya. Pero kasi mali siya, dapat nandito lang yon. Pag i-move natin to 1, 2, 3, 4, 5, 6. Ang totoo, ang tamang scientific notation nito is 1.0 times 10 raised to the power of negative 6m. So anong mas malaki ang value? Siyempre ito, basic pa rin. Okay. Basic substance pa rin siya. Mas malaki pa rin ang value nito kesa sa H plus. And then before we'll end, we'll answer the letter C. Kasi let's have naman an example wherein the H plus is given. Okay? So pag H plus ang given, anong hahanapin? The OH. Pero ganun pa rin yung formula natin. Ganito pa rin siya. And then we will use the same constant. This one. This time, the H plus is given. You're going to compute for the OH negative. So divide both sides by 10 para ma-isolate natin dyan si OH. So 1.0 times 10 raised to the power of negative 4 divide 14 kulangan. Tingnan ko may something wrong. Negative 14. Okay. Negative 14 divided by 10.0 is 1.0 times, ano answer niyo dyan? Anong exponent nito?
Negative 15, ma'am.
Okay, very good.
Negative 15.
15. So ito yung answer. 1.0 times 10 raised to the power of negative 15. Neutral, acidic, or basic? Again, neutral, acidic, or basic? What do you think? Dito tayo mag-end. Ano na dyan? Ano na dyan? Ano mas malaki? Ito.
Acidic. Gawin.
Ha?
Acidic.
Acidic. Siyempre, class acidic. Kung titingnan natin, actually, 10 na good na siya. Whole number na 10. Ito, 1.0 times 10 raised to the power of negative 15. Kung imuhan niyo siyang i-decimal, tanggal yun na ito ang scientific notation, 0.0000 hanggang 15 places, no? So, mas malaki talaga ito. So, automatic, kung malaki ang H plus, diba? Acidic. Okay? So, that's how you compute for the amount of hydrogen and hydroxide ion in a solution and determine whether the substance is acidic, basic, or neutral. Now, to end, let me give you an assignment. Pasan nyo lang ito sa Schoology class. Mag-post lang ako ng submission din. Ganun pa rin yung instruction. Compute for the following solutions. Following solutions at 25 degrees Celsius and identify whether it is acidic, sorry for sa kung agi ha, basic and neutral. Ano nang agi basta nagadali. So number 1. Number 2. Okay. Ayun lang. Show your solution yan ha. 2 decimal places if ever may decimal. Yeah, mag-quiz tayo tomorrow. Please prepare sa akong gi-lesson kagaina of last week. And then, submission of the activity number 4 also, please do not forget. And I might or might not give a quiz sa laboratory also, so please prepare na lang din.
Apil ni siya o ma'am.
So you study. Yeah, oo. Oo, apil niya siya. Tomorrow. Okay na? Sige. Do you have questions or clarifications? It's already 9:31 there. Naglampas na.